All right, welcome back. So now let's get into the process video for the applications of trigonometry. So what we're going to do here is just kind of start off with the dot product. Again, typically the dot product is just going to be a scalar, our geometric kind of projection between the two vectors. So all we simply really need to do is multiply your horizontal components and then multiply your vertical components. And then you need to add them together, and that is going to give you k. So I'm not really sure what happened here. So let's go ahead and actually rewrite. I'll have to go and fix that out. So there are no parentheses there. Okay, so in this case, my u dot v is simply going to be 3 times negative 1, right? So that's the coefficient of my I here. And I'm going to add that to a 2 times negative 4. Okay, so therefore we have a negative 3 plus a negative 8, which is going to equal a negative 11, okay? And basically what that means, if you can kind of take like your original vector u, you can see we're going in this opposite kind of direction from on there. All right, or the scalar is going to have that negative. Then again, we could also look at this. So if I'm going to do my u dot v here, again, you're going to multiply your horizontal components. So that would just be a negative 1/2 times a 4. And then we're going to add that to a 3 times a negative 2/3. Okay. So then in this case, that's going to give us a negative 2, and this will give you a plus a negative 2. I'm sorry. Yep. Yeah. So that's going to equal a negative 4. And voila, there we go. All right. So now we're going to go and take a look at the angle between two vectors. And again, basically what we simply want to do is, just go ahead and find the magnitude kind of for each one separately. And then you can go ahead and find the product. And then you can just go and really use that into your calculator. So it's just going to be a lot of practice with using the dot product and finding the magnitude. Just remember the magnitude of a vector. Any vector u, that would be like u1 squared plus u2 quantity squared. Okay. So, all right, so what I'm going to do is I'm going to do the magnitude to the right, and then I'll do the dot product below, and then we'll go ahead and figure everything out. So if I was going to do the magnitude here of u, and actually, you know what I could do? You can just actually type this all into your calculator as well, since you're figuring all of this stuff out. But I'll just kind of run this right. 1 squared plus 2 square root of 3 squared. And then we have the, oops, that's magnitude of v squared. And that's going to be 1 plus just negative square root of 3 squared. Okay, I do just want to kind of see, just to make sure, I think it's a little bit easier to kind of see what it is we're going to be taking the square root of. So in this case, we'll have 1. 2 squared of 3 squared is going to be, that's going to be 4 times 3 is 12. So that's going to be the square root of 13. And then over here, that's going to be a positive 3 plus 1, which would be 4. So that'd be the square root of 4. Right. So the nice thing about this is if we're going to do now the dot product, u dot v, you can see that's going to be a 1 times 1 plus, and then in this case, we're going to have a 2 square root of 3 times a negative square root of 3. And so let's see what is this going to give us? That's going to give us a 1 plus a 2 times negative square root of 3 times square root of 3. So that's going to be negative 2 times 3, which is a negative 6, which is equal to 5. Okay, so in our calculator, if we have the cosine of theta equals 5 divided by, let's see, 2 times the square root of 13, then all we're going to do to find for theta, we're just going to have theta equals the cosine inverse, right, of 5 over 2 square root of 13. All right, so now we're going to go and use our calculator. We will look at this in degrees. And let's go ahead and see here. So I can just do 5 divided by 2 times the square root of 13. And I'll do the cosine inverse of that answer. And I get a 46.10 degrees, which looks roughly about pretty good. 46.102 degrees. And there we go. All right, so let's go and do same exact thing for this one. So again, let's just go ahead and find the magnitude first. So again, that's going to be negative 3 squared plus 5 squared. So therefore, that's going to be 9 plus 25. So that's going to be a square root of 34. And the magnitude of v, That's going to be the square root of 2 squared plus negative 7 squared. Just remember you're squaring the negative 7, right? So that's going to be a 49 plus 4, which is going to be a square root of 53. All right, and then let's just go ahead and do the dot product. So u dot v is going to be a negative 3 times 2 plus a 5 times negative 7. And again, I just like to do all the work to make sure we're practicing a lot of the magnitude and dot product to get good at it. And also when you type in a lot of things into your calculator, it just makes for things to make mistakes. All right, so in this one, I end up getting, let's see, this ends up being a negative 6, and this is what, a negative 35. So that ends up equaling a negative 41. All right, so when I do the cosine of theta equals negative 41 divided by the square root of 34 times the square root of 53. So theta equals the cosine inverse. Let's go ahead and move that up. Theta equals the cosine inverse of negative 41. Fix that. Divided by the square root of 34 times the square root of 53. All right, so now we'll just do a negative 41 divided by parentheses square root of 34, close parentheses, times the square root of 53, close parentheses. And I'll do the cosine inverse of that answer. And I get 164.981, which looks pretty good. So theta equals 164.981 degrees, non-rounded. I'm just going to be truncating. Okay, so now let's go and take a look at the next one, which we at least look at some fractions. We're like, all right, maybe I don't want to do the magnitude. You could. Again, you could just type it into your calculator, and that's perfectly fine. But it doesn't look like it's going to be something easy that we're going to want to add and take the calculator form of, right? So one thing I might want to look at with this case is like, why don't we just check the dot product first? Because I kind of see something going on that I think might be helpful here. So if I had negative 2 times a negative 3, and then plus, that's going to be a negative 2/5 times 5. So what happens here is when I do this, the 3's divide out, and I have a positive 2. And here the 5's will divide out, and I'm going to be left with a negative 2. Well, that equals 0. So again, this is kind of interesting because if I have the cosine of theta equals 0, right, divided by, whatever the magnitude is, who knows what the magnitude is. But again, the cool thing is it doesn't matter because if I have 0 divided by anything, that's still just going to give me the cosine of theta is equal to 0. Now, if you take the cosine inverse of 0, and again, that if you go by your restrictions, you're going to get 90 degrees. So therefore, you can see that's why one of that plays into like the angle between two vectors. Like you can see that when your dot product is equal to 0, the angle between two vectors is going to be 0. Okay, so as we go and look at the next example, a lot of people sometimes will look at this one and they'll think, oh, numbers are going to cancel out. So, you might want to start by using the dot product, and that's perfectly fine, again, for this case. But again, like when you notice this here, what happens is 10 times negative 10, well, that's going to give you a negative 200, right? And then over here, what you have, again, is, oh, that's the exact same thing, right? So that's going to be plus a negative 200. So they don't cancel out. Those just equal, that's a negative 100 times a plus a negative 100, which equals a negative 200, right? So that's a negative 200. All right, so now let's go and look at the dot product. Now the magnitude is going to be rather simple, pretty easy to compute anyways, because, we just know it's the square root of 10 squared plus 10 squared, right? Which is going to be 200. And the magnitude of v, in this case, is going to be negative 10 squared plus negative 10 squared, which is, again, 200. So in this case, I have the cosine of theta equals, let's see, my dot product, which is negative 200, divided by the square root of 200 times the square root of 200. Well, the square root of 200 divided by the square root of 200, guys, is just going to be 200. So I have the cosine of theta equals negative 200 divided by 200. Well, that's just going to be the same thing as cosine of theta is equal to negative 1. Now, if you take the cosine inverse of negative 1, what you're going to get is theta equals 180 degrees, right? Which, again, would make sense if you look at these two vectors. This one is going up and to the right, and this one's going down and to the left, exact same distance. So you can see the angle between those is going to be 180. So when you have those vectors that equal, have that angle between them as 180, we could also call them parallel. But a lot of this is a lot of work just to determine if something's parallel, orthogonal, or neither. So that's why we like to just kind of simplify it and take a look at things to kind of see like, hey, does the dot product equal 0? If it does, then they are perpendicular or orthogonal to each other. If they are not, then check to kind of see their slopes. You can go ahead and find the angle between them to be 0, 180. In my opinion, it just kind of seems like that's a lot of work to determine if something's parallel. And if that's not the case, then you can just go ahead and determine that they are neither. So we got 4 examples. Let's go ahead and get started on this. First thing I like to do is just kind of identify u dot v. So in this case, I'm going to do 3 square root of 3 times the square root of 3 plus negative 9. So basically, does this equal 9? Which guess what? It does. Okay, so since you can see here, these are orthogonal. There you go. All right, so the next one is, again, let's do u dot v. So this is going to be 1/4 times 8 plus 4 times 1/2. Okay, so 1/4 plus 8 is going to be 2. 4 times 1/2 is going to be 2. Well, they both equal 2, but again, you're adding them to equal 4. So now let's just go ahead and check the slope. So 4 over 1/4, is that going to be the same as 1/2 over 8? Well, again, what we could do is multiply by the reciprocal, right? Oh, come on, I hate that. Come on. And what you'll get here is 16, but if you multiply by the reciprocal over here, you get 1 over 16. So these are not parallel nor orthogonal, so these are neither. All right, let's go and take a look at another one. So again, check the dot product, u dot v. So that's going to be 1 times negative 3 plus 4 times negative 12. In this case, we're going to have negative 3, and then that's going to be a negative 36. So nope, that's not working out. So that equals a negative 39. Let's go and check the slope. So 4 over 1, is that equal to a negative 12 over 3? Well, 4 over 1 is 4, and negative 12 over 3 is, negative 12 over negative 3 is equal to 4. So therefore, we can say that these are going to be parallel. And then last but not least, this one, a lot of times people look at these numbers and assume they're either parallel or orthogonal. But again, like, do the work. You can do some math ahead of time, but just don't look at the numbers and just assume. You want to make sure that you can, do the proper calculations. Because what you get here is a negative 12 plus negative 12, which is a negative 24. And then if you do the slope, you would say 4 over negative 3, which is not equal to negative 3 over negative 4. Right? So you can see how this does not, 4 over 3, sorry. But still, one's positive, one's negative, right? Or actually, they still both to be positive, but they're not the same ratio. Does not equal a 3 over 4. So therefore, this is another example of neither. All right, so now let's get into some word problems, and we're just going to kind of work on 2 word problems that we have here. So again, first thing we're going to do is draw a description of the scenario. We're going to label its parts. We're going to define our variables. And then we're going to create our vectors to represent the situation. And then we're going to check our work, make sure it makes sense. So kind of like what we did in the warm-up from the introduction, we're going to want to make sure we set up our scalars based on some angles as well as the magnitude. So in this example, it says an airplane is flying due east at 378 miles per hour. Okay, so if we have an airplane flying due east, okay, and that's going to be at 378 miles per hour. Now, we can go ahead and write this as a vector. So I'm going to say A. So let A equal the airplane. Okay, so we can write this as a vector. So this would be 378 times the cosine. Let's see, that's going to be 0, right? So the cosine of 0, comma, the sine of 0. All right, and it begins its ascent with an angle of depression of 30 degrees. It is met with a strong wind. It's flying due east. Okay, it begins its ascent at an angle of 30 degrees. Due west at 40 miles per hour. What is the final speed and direction of the airplane? Okay, so this is actually going due west, but it's actually going down at 30 degrees. So we are going to actually change this here. So, no, not that one. So I'm actually going to say, all right, so the airplane actually has its descent at negative 30 degrees. Right? So it's going due west, going due east, but it gives its descent with angle of depression at 30 degrees. It is met with a strong wind due west at 40 miles per hour. Okay, so the strong wind due west, we could say from that. So we'll say W equals wind. So my wind is going to equal 40 miles per hour. And that, I would say, is going to be at, you can call this an angle of 180 degrees, right? So basically what we have here is it is flying due east. So let's see what we have here. All right, so we have this going down, and so we can recommend this at 30 degrees, okay? And so that's going to be your airplane. And then what we have is we have the wind coming in like this, okay? So what that's going to be doing is slowing down the airplane. So we can say the cosine of 180 degrees, comma, the sine of 180 degrees. All right, so wind and airplane. Good. So basically what we want to do is like, what's going to happen? Like, how is this? It's obviously slowing down the airplane, right? So what is going to be the final speed and direction of the airplane on its descent? So all we simply need to do is this is what we call the resultant vector. It's just going to be A plus W. Okay, so what we're going to do is let's go ahead and figure out what our airplane is. And then we're going to go ahead and figure out what our wind is. So let's go ahead and do 378 times the cosine of negative 30. All right, and you know what I'm going to do? That's as a 327.35. Now I'm going to store that as A. Oops, clear. Store it as alpha A. And then comma. Then let's go ahead and do sine of, so 378 times the sine of negative 30 degrees. And that's 189. Okay, so that's 189. Negative 189, sorry. All right, so I want to save this. So let's maybe move this over a little bit more. Okay. Just to give myself a little bit more space here. Don't want to feel like I'm being smushed here. So I have store this as alpha A and then negative 189. Okay, and then over here, we're going to do 40 times the cosine of 180, which hopefully you know the cosine of 180 is negative 1, right? So that's just going to be a negative 40. And then this is going to be sine of 180. Well, hopefully you know that's going to be 0, right? But I'll just still type it in just to make sure that I have everything. And 40 times the cosine, 40 times the sine of 180. Okay, and that's going to be 0. All right, so now all we simply need to do, if we're going to add these, then I'm just going to do my stored answer A plus a negative 40, comma, my stored or my negative 189 plus 0. All right, so I'm going to do alpha A plus a negative 189. That's going to give me 138.357. And then my, and then I have negative 189 plus 0. So that's a negative 189. Okay, so that's my resultant vector, right? So it was at 327, negative 180. Now it's only at 138, right? So that's going to be this. You can see my vector got resulted, right? It's a little bit slower. Now, again, we still need to find our, our direction, like our final speed. So our speed is just going to be the magnitude of r. So speed is going to equal to the magnitude of r. Okay, so I'm just going to type this into my calculator. Now, in this example, I'm going to store this as my alpha b. Actually, never mind. I can just do that. I can square this answer plus negative, let's just do 189 squared. And then I'll take the square root of that answer. Okay, which equals, right, the square root of 138.357 squared plus negative 189 quantity squared. Okay, and what we get here is going to be a 234.23, and let's see, that's going to be miles per hour, which makes sense, right? The plane's originally traveling at 378 miles per hour, and it has a headwind, so it's going to be going slower. And then I said, find its final speed and direction. So let's go and find the angle here of this vector, right? So obviously, if it's going at 30 degrees, it's obviously being slower, so it's probably going to be going down at a different direction. So let's go ahead and take a look at this. So we have the tangent of theta is going to equal a negative 189 over 138.357. All right, so theta equals tangent inverse of negative 189 over 138.357. Now again, I'm using the full answer inside my calculator, but I'm just writing it down shortly for there. So that'd be negative 189 divided by 138.357, 6026. And now you can see that is going to be at an angle of negative 53 degrees, which again, like you can see that the angle of depression here, I'm just going to write that angle to be 53.793 degrees, right? So theta is going to equal your angle of depression. Okay, and your speed is 234.23 miles per hour. All right, so yeah, and that makes sense. Like if you're going at 30 degrees and you're being pushed back, you're going to be going at a stricter angle. So definitely makes sense for that. And then here's another example. In this example, we're going to have two angles for both of them. So again, it's just going to be a little bit more heavier on the calculator. That's really about it. We say a boat is traveling at 40 knots with a bearing of 17 degrees. There is a current at 5 knots that is helping the boat at a bearing of 3 degrees. So what is the final speed and direction of the boat? Now, this one's a little bit important because they're talking about bearings, not angles in standard form. So the reason why we want to make sure we're covering this one, or the reason why I wanted to cover this one again is, like if I say 40 knots at a bearing of 17 degrees, bearing of 17 degrees is right here, right? So the reason why this is important is my, B, let's say B is for boat. Okay, don't use 17 degrees, right? You have to use the angle in standard form, which is going to be 63 degrees. So we're going to have 40 knots. 40 knots is going to be the speed, and then that is going to times, we're going to be by the cosine of 63 degrees, comma, the sine of 63 degrees. Okay, and then what else we got? We got the current, so C equals current. And the current's at 5 knots, and that is helping the boat at a bearing of 3 degrees. Okay. So we have C equals the current, and that's going to be at 5 knots. And that's going to be at the cosine. Now, again, that's going to be at 3 degrees, right? So that's even smaller. Bearing at 3 knots. And that one is going to be at 87 degrees. So we say 87 degrees. Sine of 87 degrees. Okay. Now again, if we're looking for the final speed and direction of the boat, we're looking to combine these. Okay. But the first thing we're going to want to do is actually figure these out. So what I'm going to do is type my calculator. I'm going to do, all right, so 40 times the cosine of 63. And that's going to give me a 18.159. I'm just going to store this as alpha A. And then I'll do 40 times the sine of 63 degrees. And that's going to be a 35.64. And I'm going to store this as alpha B. Okay, so what you can see here is now, it just makes my life a little bit easier to store this as alpha A and then store this as alpha B. All right, so then C over here, I'm going to do 5 times the cosine of 87. That's going to be 0.26. Wow. Takes 1, and then 5 times the sine of 87. And that's going to be 4.99. Oops, crap. Let's store this as D. Okay, so I'm going to store that as alpha D. I'm going to go back to my original answer, or my 0.26. I'm going to store that as alpha C. Okay, so therefore these are going to be stored as C, comma D. Okay, because the reason why is I want to find my final resultant vector, right? So R equals the resultant of boat with current. Okay, so what that's going to do is you're just going to do alpha A plus alpha C, comma, alpha B, plus alpha D. All right, so alpha A plus alpha C, and that gives me a 18.421. And again, I will store that. Let's just store this as alpha E. Oh, we already did E. Yeah, no, we store this as alpha E. We'll just keep on going up the alphabet. And then over here, I have alpha B plus alpha D. And that's going to be a 40.63. And again, I'm just going to store these as alpha E and alpha F. Okay, and you don't really, I think it's just going to be helpful. So now when I'm rewriting these, that you kind of know what I am referring to. Because again, our final speed here, right? So the speed is going to equal to the magnitude of R, right? So again, all that is my alpha E squared plus my alpha F squared, right? That's all the speed is. And my angle, my tangent of theta, is just going to be my alpha F, my stored F over my stored E, right? And theta is just going to be your inverse of that. So let's go and do that. So we'll do the square root of alpha E squared, square root of alpha E squared plus alpha F squared. And I get a 44.64, which kind of makes sense, right? If it was originally going at 40 knots and it has a current behind it, it's going to be going a little bit faster, which is 44.614 knots. Okay, and then my angle here, which originally was at 17 degrees, but it has like a current that's a little bit more to the left, not too much, so it shouldn't be too far off. But let's just see what this is off. This is not that heavy of a current left and right. So I do F divided by E, and I do the tangent inverse of that answer. Stored F divided by E, that's going to be at 65. Okay, yeah, it was at 63 degrees, so that's going to be at 65 degrees. And what I do is I just do 90 minus that answer. There you go. No, that's not right. That's at 24 degrees. 70, 80. Did I mess that up? I messed this whole thing up. Oh my God. You gotta be kidding me. Yeah. Okay, you know what I'm going to do? I'm going to change this problem because I am not going to work through this. That's going to be a 27 because I am not going to be working through this whole thing out. So now the angle is going to be a 24.387 degrees because thankfully I did not go ahead. I can reprint out this worksheet and I cannot believe I made that mistake. So rather than fixing all those, I'm going to stick it with that and we'll just change this answer to 27 because that is a lot of answers stored and that was a lot of work. But hopefully you understand to be very, very careful with yours. That is a bearing of, right? So you can see as I found the angle, and I should be careful here. So my theta, my angle ended up being a 24.387. Okay. But that wasn't the answer they were looking for. They were looking for the angle, right? So we're going to say that's a bearing of this angle. And all I did, no, I'm sorry. What am I doing? My angle wasn't that. My angle was, sorry about that. When you get this into your calculator, you get a 65.612. That's what your calculator gives you. Okay. So then you just need to subtract that from 180. So 90 minus theta equals your bearing. There we go. And there you go, ladies and gentlemen. That is it for our process for this section. Now go ahead and check your understanding, and I'll look forward to seeing you in the next video. Cheers.